This presentation is optimization of resource of digital radio transmission over IBOC FM through MÁ√₂ partners. And the project regularly recommendation for the transition from analog to digital radio in Colombia. The present project was carried of the within from the framework of the project LITTLE, regulatory recommendation for digital sound broadcasting if in commendation for a digital sound broadcasting transmission scheme according to the need and the physical resource of the radio in Colombia. The engineer involved in this project included Carroll, which is currently speaking. Engineer William Cuevas will speak after me. Engineer Rico, Engineer María Rodríguez, Engineer Juan Carlos Vesga, Andrés Diaz. With the financial sponsorship of Colombian Communication Regulation Commissions. The presentation includes 2 topics, introduction and context in the algorithm, and maximum fairness equality algorithm. Introduction. The IBOC in band of channel radio standard is a digital broadcasting technology used in transmission of AM and FM radio signal of a raw station to seamlessly broadcast analog and digital signals of the same frequency. These frequencies analogic and these frequencies digitals. Difficulties faced with digital radio of FM. Compatibility of device, implementation cost, bandwidth and computation, interfaces issues, slope adoption. Techniques to improve spectrum management. Adaptive modulation, efficient compression techniques, interference reduction technologies, usage of C-band and complementary spectrum, spectrum planning, monitoring, and dynamic management.
Well, the technique that we use was max-min fairness quality algorithm. The max-min fairness is algorithm that has been used in various research works related to the allocation of records in environmental. Its algorithm is known as max-min fairness, which originates from cooperative games theory. It's an algorithm to probability. And the benefits of this algorithm is equity in signal quality, improve user experience, optimization of spectrum use, that it is that we centered is allow for more efficient or use of available bandwidth by dynamic allocations resource according to the individual needs of each station. This can maximize spectrum use and over virtualization of certain frequencies. Reduce the interference, adaptability to the channel condition, dynamic bandwidth allocation, priorization based on signal quality. We have some papers of reference that use the same algorithm, how resource optimization in IBOC FM, the results are 20% improvement in the signal quality for a station with lower performance, other efficient compression techniques for IBOC, 30 reduce in required bandwidth, analysis of dynamics spectrum management in digital radio, adaptability to channel change, spectrum use optimization, social impact and regional development through innovation service and IBOC, optimization of adaptable modulation and IBOC, interference reduction and IBOC radio digital, and impact of continuing education on IBOC technology adoption, please, excuse me. These papers are getting to our paper how reference, but this is a scenario proposed to project. We have 12 nodes or digital broadcasting station carry out hybrid IBOC transmission process over FM uses an RF channel, which for this particular case is considered to provide a total bandwidth of 16.00 kilobytes per seconds due to the various conditions that may affect the channel's maximum performance. The next tables present the list of the 12 IBOC FM transmits node. We have some service of one service for node. For example, music, interviews, news, sport, which application use one bandwidth in kilobytes per second. All the nodes use 20 kilobytes per second, but we have only available 16.00 kilobytes per second. Is necessary optimize the bandwidth for this season. For this, I use the optimization with the max-min fairness techniques compared with linear programming. This algorithm is used MATLAB and we use a summatory of max term and a probability in this, where n, di, and xi correspond to the number of the nodes, the bandwidth required by node, and the bandwidth allocated for node respectively. The question that describes the algorithm is 1, 2, 3. The result of we obtain with program linearly is this, and the bandwidth use the max-min fairness techniques is this. We show that the bandwidth use the max-min fairness is more optimal for the application in the bandwidth. Order to evaluate the use of the max-min fairness algorithm as optimization strategy in RF network over IBOC FM performance at better result allocate process that the program linearly. The following hypotheses are proposed. We propose two hypotheses described on equation 4 and 5. The acceptance range for hypothesis 1 as this T less the T alpha n minus 1 at 5%, significance at alpha equal 0.05 and n minus 1 degrees of freedom. For the specific case, the value of T for this case is 1.7959. Defining the acceptance range of the hypothesis as minus infinite to 1.7959.
And the conclusions. Implementation of max-min fairness as a strategy for resource optimization in IBOC FM presently benefits compared to the current condition. By progressing equity in resource allocation, this strategy offers a significant improvement in signal quality for our stations, ensuring optimal performance event for two-way with worse transmission condition. Furthermore, by reducing interference between signals and maximum spectrum utilization, it promotes harmonious consistency between digital and analog transmission and can lead to overall quality of the radio frequency spectrum based in obtained results. It was evident that the use of the maximum firms algorithm yielded excellent outcomes in determining of the firm resource allocation with the values provided for each service class with 95% confidence. Compared to the linear programming, supported optimization model, additionally, it was observed that the total bandwidth assigned to each mode correspond to the total bandwidth available of RF channel, even on the channel saturation state. Thank you.